Hello again to second time. So we will start with Kubernetes journey. If you don't have a Terraform, kubectl, or Azure account or Azure CLI, it's better you to like set up because otherwise you cannot follow the examples. But right now, since we will start the introduction to Kubernetes, and if you just don't understand something, probably it will grow up like a snowball. So that's why maybe you can just do the setups later. I will give you a time. And if you have any questions, just ask right away because if you don't fix things, it will go a snowball. So today we talk about mainly what is the Kubernetes, why we use it, and the components of the Kubernetes. And then we will do a couple of demos together. We will deploy and hello world application. And after that, if we have a time, we will also deploy the applications you Dockerize yesterday and do CI/CD with it. So let's start it. And as always, yes, we are paid by doing these things, and I'm a consultant about these things. But here, the information we share may be not updated. So if you do something on production, it's better you to do your own research. So what is Kubernetes? So as we speak today, the Docker or generally the containerization not fix all of the issues. Like it's fixed quite issues, but it's just bring us new issues to fix. So the Kubernetes is for fixing these issues. It's basically an orchestration tool. It's basically a smart way to run the containers on somewhere. Uh, and also like stay continuously make sure that your container is running. You can schedule the deployments and you can just manage the application monitoring without any manual intervention. And why the Kubernetes? Because Kubernetes is, firstly, it's easy to scale. If you want to scale it, if you need more thing, you can just add node and then it will just scale. Let's imagine that you are going with common traditional ways and you have a bunch of servers and you're running an applications and your applications running in Docker, but you just run there with like Docker Compose, or you just use the systemd for make sure that the containers is always up when this machine is restarted. And when you want to add new servers because you need more capacity, you have to do a lot of additional setups. But in Kubernetes, Kubernetes is a fleet. You just put this new instance to fleet, and then the Kubernetes will be take rest of them. And also it is flexible, so you can just run it in your MacBook. You can just run it in your home server. You can just run it in your data center, or you can just run in the cloud provider. Or maybe you can just run multiple cloud provider, or you can do hybrid. You can do capsule. By the way, using half of the cloud infrastructure and half of the your own structure, we call this hybrid. And if we are running the management of the control plane, I will explain it later, to the cloud, we will call this a capsule. And uh, there's a really rich ecosystem. There's a lot of people who is like doing a lot of different tools with it. So you can just like fund any kind of tool or any kind of expert in anywhere in the world. They may a little bit expensive, but you can just like find what are you looking for really easily. And who should use the Kubernetes for? Kubernetes is a Swiss Army knife. So it has a lot of features, and sometimes you have to be a little bit precise about doing some stuff. So if you have a large team and if you have a complex microservice architectures, it is good tools to use. Or if you are hybrid cloud environments or multi-cloud environments or multi-regional environments, uh, it's good if you need a high availability, high scalability, or if you don't have a uh, fixed traffic, Kubernetes is really good tool to use, but if you're just a startup with bunch of guys and writing a monolith application, I'm not sure Kubernetes is the good tool for you to use on the production. Of course, it is like fun to play with it, fun to have experiments it, but I think there's the better options if you have a couple of containers. And we will start with the Kubernetes components. So first component names node. So when I say node, I'm saying that a machine, this can be a physical machine or this can be a virtual machine, which we like set up the Kubernetes in it. We have different type of nodes. Uh, In this example, as you can see, we have a one control plane and three nodes. I will explain the control plane later, but the nodes are the computers which our containers will actually run. And in this nodes, we have a some process named kubelet. And this kubelet is the one who manage this physical or virtual machine itself for Kubernetes. And also we have node pools, so you can actually group these pools and say that, hey, these are my Linux pool, these is my North America pool, this is my NVIDIA GPU pool, and then you can just say that you can just like, oh no, oh yeah, really? Oh, okay. I am not sure if I switch them at least for half an hour. Okay, hopefully it's working for you. Okay, okay. So you can just like have different configuration of different purposes for these node pools, and you can say that, hey, these are the NVIDIA nodes, and like let's imagine that your company has a AI team, and this AI team like train some AI models, and they need NVIDIA GPUs, but the other people in your company, they just running regular API services and they don't need GPUs. So you can just assign like different physical servers or different capabilities with different node pools. And this node pools is usually we are usually using this in when we run things in cloud. Usually, if we run things in on-prem, we are not using node pools. Uh, you can of course use it, but it's not kind of common practice. And we have control plane. The control plane is heart and brain of the Kubernetes. In this control plane, we have some process named API, and this API is our entry point to cluster. So if you want to give an order to Kubernetes, if you want to say, hey, uh, just run this container in this specific node, we are saying to control plane, and the control plane connects the kubelet inside of the node and say that, hey, run this container or do this action or like what is your CPU usage or this kind of thing. So the control plane is usually small, not too much resources, but since it is the brain, we are not actually running any container of ours. Like, of course, there's some containers running in control plane, but we are not actually running our applications. We are running our applications in the nodes, and the control plane, it is for controlling the cluster. Also, control plane has small, tiny database thing in it for uh, having the state files or having the configuration YAMLs. And also this control plane have some scheduler like cron jobs, and it's schedule some stuff. So the control plane is the management. And usually when we run on-prem cluster, we running this control plane by our own. But if we are running this thing in the cloud in a managed way, usually the control plane is given by a cloud provider. In our case, Azure will provide us the control plane, and we will just use it. And yeah, and also we have a something named kubectl. kubectl is a CLI interface. Yeah.
Well, the control plane, why is it called plane? And does it run on a separate node, or where does it run?
It's just a node by itself.
The node on itself.
Yeah.
Dedicated purely for.
Yes.
Okay.
Yes.
So we have to kind of waste one node, like one server.
It's a tiny node. It's a tiny node. Like you can imagine that 2 cores and 4 GB RAMs. It's a tiny node. Like the other nodes can be like huge nodes, but this one is a tiny node. And also like you can use it as a virtual node as well. Like you can just run it in virtual machine. Oh, by the way, in production setups, usually we have more than one control planes, because if you lost the control plane, you lost the whole cluster. You cannot give order to cluster, or you cannot run scheduled tasks. You cannot, the housekeeping works. So usually if we are running a production environment, we are running more than one. Actually, the control plane itself is sometimes cluster. And also we have some other product named Rancher, which I don't want to like discuss today, because it's kind of like we say that the Docker come and fix some problems and then cause new problems, and the Kubernetes come and fix some problems and cause some problems, and the Rancher is the one who fix Kubernetes problems. But it's not today's topic. I will not go there. Uh, this is a dev setup, so there's only one control plane, but usually there's more control plane.
So when you say a node, is it possible that you might mean control plane node, or what's the proper nomenclature here?
Control plane node.
Control plane node, or
well, sometimes I'm calling it API.
Okay.
So sometimes I'm calling it control plane. Like since we are running in the cloud, we actually don't have many uh, functions with that, so we will not play with that too much. Is stream is working? Okay. Yeah. So we have some tools to run to manage our Kubernetes cluster. One of them is we can, of course, directly connect the API and manage the Kubernetes cluster with API calls. And one of the other thing is using UI. And this UI is actually a front end on this API. So it's just like same entry point. And also we have a CLI tool named kubectl. So this kubectl is basically a CLI tool, which is using these APIs. It's a kind of API client. And today we will use a kubectl. And also sometimes cloud provider also have their UIs on top of these APIs. Also, if we have a time, we will check uh, how Azure manage things in UI side. But I'm not sure if you have a time. Okay. So this was the control plane and the pods. So in one node, we have many pods. And in one pod, we may have many containers. So pod is actually an abstraction layer on top of a container. So pod is the smallest thing in the Kubernetes. In one pod, there may be one container, or there may be more than one container, but 99 of the cases, we only put one container in a one pod. And we are running these pods in the node. So you can think that a pod is actually a wrapper of a container, a secondary container that which we put a Docker container in it. By the way, you can just use another container technology. You don't have to put a Docker container in it. 99 of the cases, we use, of course, Docker containers, but also you can put different kind of technology containers inside the code. but there we are not often use it, and they are usually not working well. So I never see actually someone doing that. But the basic thing is, let's say that the pod is the smallest component and it runs our application in it.
So the smallest component does mean that you don't have direct control over Docker containers inside the pod.
Well, yes and no at the same time. So if you want to pass an environment variable, you can pass it. If you want to jump inside it, the container, if you are debugging something, yes, you can jump in it. But we are not writing Docker run inside of the pod. Pod do this for us. Any question about pods or nodes? No? Okay. Oh, by the way, uh, we usually have three nodes in small clusters or one node. Uh, Today we will only deploy one node because of the cost, but usually we are not deploying two nodes. We are deploying one node, three nodes, or five nodes. So because okay, I will tell later why we are doing that.
Uh, in Docker, we have a network.
Yes.
So in the pods, can we control networks, or it is, or how can we?
So the pod manage the network for your container, so you don't have to worry about that. These these all of the pods is inside the Kubernetes network itself. So you don't have to manage them. But if you have a specific need, for example, if you have a more than one pod, more than one container in a pod, you may also manage it as well. But mostly we are not managing it. And also the examples like why we have a two containers in one pod is usually sidecar containers, or usually we are running like Prometheus agents or Loki agents for log purposes. Because imagine that you have a one application, there's a one front end code, one backend, and one database. You can put all of these three of the containers in a one pod and run as a pod, but it will be not a good idea because uh, when we want to scale something, we want to scale just the thing we want to scale. For example, let's imagine that I have an application and this application has a microservices. And this microservices is like accounting, payments, search, register, and cart. And let's imagine that we have an e-commerce website and our marketing teams creates a campaign. And this campaign, just people go and buy free stuff. So, but if they register first time, so this means that our registration service will be use high CPU and memory, high demand, because the campaign is focused at the new registered users. But the other services like accounting service, well, there will be, of course, a little bit more load on it, but not that much. So basically, we only want to scale the register process. But if we put all of the containers in one pod, and because we cannot say I need 5 containers, we can say that I need 5 pods, scale 5 pods or scale 20 pods. So since we want to scale everything one by one, uh, it's not a good idea to put two business logic in a one pod.
Um, how about cross-cutting concerns like logging? So, for example, you have an accounting service that you want to
Yeah.
set up, and usually the process needs some logging activity to do, right?
Yeah.
So, do you want? And I think you usually want to scale up logging as well together with that service, right?
Yeah.
So, do you put it together with all the containers? I mean, with an accounting container, or do you create a dedicated pod just
Well,
for that purpose?
There's a different type of ways to do log management. And usually the way I do, I'm using Loki stack. I have a Loki, Grafana, Prometheus, and sometimes Elasticsearch. So the general log database is usually Elasticsearch, and they have a different namespace, different containers, different pods. Grafana has different pod, the Loki has different pod, but sometimes you need the agents to interact with your pod. For example, in Prometheus, when you set up Prometheus SDK to inside of the code, it's just expose some URL names Prometheus metrics, and when you go there, it just gives you the metrics. And sometimes you just don't want to open this matrix URL to outside. So then you just put a Prometheus agent inside of the pod, and that Prometheus agent is crawling your containers metrics. And this agent send these logs to the uh, a general pod, general logging mechanism like Loki. So in this case, yes, of course, the logs has own engines, own storage, own databases, and own interfaces. But also sometimes you're using this agent to crawl inside of the container. But if you don't have this type of needs, by the way, you can also uh, using Kubernetes API, you can also get the console logs of this container as well. So if you just want to get the console logs, you don't need to put an agent in it. You can just ask a Kubernetes API for to give you. Yeah.
The box can be different resources. So some of the box type do, but some of them
Not the pods, but nodes, yes. Because pods are like abstractive layers, so pods are actually nothing. But the nodes, I mean, imagine that we have 5 different computer here, and 3 of them has running like regular CPU, and the 2 of them has NVIDIA GPUs. And if you run your pod inside of that node, also theoretically your pod and your software inside of your container can access and use the NVIDIA GPUs as well.
you can set up the device, right? So you can have one file, but also one must have the access to and all.
Yes, but yeah, technically you can think that, but I usually think pod equals a container. Because since usually we are not putting more than one container in, and we usually not manage inside of pod network. So, and this pod has one IP address inside the cluster. So if you have a more than one containers in a pod, it's exposed outside as a single IP address.
So can we say the node as a server?
Yes.
So in one server, how many nodes we can install, set up?
In one node, how many pods we can set up?
In one server, how many?
In one physical machine. Well, with virtualization, you can just set up like as much as node you can. Like if there's enough resources in the like let's imagine a giant server with like 500 cores and 20 terabytes of memory, and you can just set up like many different virtual machines, and you can run many different nodes in it.
So if I understand, Kubernetes and both nodes, they uh, divide our server into
Yes.
partitions, like
Yes.
Docker, and just we can easily configure it.
Well, usually we are setting only one node to only one server. If we have a bare metal server and if we want to set up more nodes, we usually do virtualization, like using hyperware or VMware and setting 5 different Linux machines and running 5 different nodes in it. But in on a single operating system, Can you set up more than one node? I don't know actually. Uh, but if it is possible you to do that, I don't think it is logical way to do that, because why we have many nodes? Because we are saying that if one of the nodes die, the other nodes will keep the cluster running. So, and also we usually try to set up these nodes to different physical machines, because if we have a issue on physical machine layer, if somebody like plugs the electricity, or if somebody just like attacks the physical server with axe, we still want it to be running. So it may be technically possible, but I don't see any reason why we set up many nodes in one machine. Yeah. So, okay, no question, right? Then I will start at replica sets. So we have some sets. I will cover the three of them today. We have something named replica sets. And you can say that, hey, I need 5 exactly same pod. And this is running a 5 exactly same pod for you. When I say exactly, of course, they have a different IP address, but I mean the replica of 5 pods. And you just say that, you guys remember in Terraform, I just say something, hey, there has to be a server here. And when I delete it by hand, or when I change a configuration by hand, what's happening? When the Terraform run the second time, or configuration will be go to the exactly same, right? So the replica state is the same. For example, you say that, hey, my desired state is 5 healthy running container. And the replica sets make sure that there's a 5 healthy running container. If one of these container crash, or if one of these containers delete, the replica set will be automatically deploy another container and try to make sure the state is 5. Even if your containers are keep crashing, it will continuously try to deploy, try to fix the issue. And uh, also, if you want to, sometimes we are saying, hey, just roll back this update. We are creating some rules. For example, we say that, hey, I want to deploy 5 healthy containers. This is your rule. And this is the 5 containers which is running healthy with the version 1. And my CI/CD is deploying version 2. So while this version 2 deploying, since it has to be always 5 deploying pod, it just close one of these pods, and there's only 4 pods. And then it's creates the version 2 pod. So in this case, we have a 4 version 1 and 1 version 2. And it just waits version 2 to become healthy. And when version 2 become healthy, it's just shut down one version 1 and put a 1 version 2. It shut down another version 1 and another version 2. If the version 2s are not healthy, it's just roll back and not deploy them. So this is the strategy you have to choose. You can choose, you can define different strategy. You can say that if I push a new version, just delete all version ones and just set up a bunch of version twos and try them to running. Or you can say that I don't want to be downtime. So keep version ones running and give the all the traffic to version one, and also deploy to version twos, and make sure when the version 2 is healthy, then switch from version 1 to version 2. These are different type of the strategies we can use with replica sets. And you have to configure each of these scenarios in Kubernetes configurations. Yeah.
Is replica set suitable for running job workers? Sorry.
Well, maybe. Like, probably I will I will use them for scheduler because I want, well, when you say jobs, I assume that the jobs will only run in some time or they will trigger if there is some new message in the queue.
Let me clarify. So I imagine a worker being a worker that runs continuously
Yes.
and picks up a job from some job source
Okay.
as it arrives, right? So they are not disposed.
You mean the arriving means the schedule.
Scheduling happens.
It may be like that. Imagine that there's a RabbitMQ or Kafka or Redis queue or SQS queue or Azure Service Bus, and there is a one container continuously crawling this queue, and when you put a new message to this queue, this will just read it and do the job, and then restart it, and then continuously. Yes, you can do that, but the main issue is here. Okay, this is a little bit software architecture than Kubernetes, but uh, okay, case we have a one system, and the users can put profile pictures, but we have to make sure that this profile pictures is pretty adjust with the core community standards. So this means that we have some AI, and this AI is running and checking this picture. If this picture is aligned with our community standards, if it's not, it's just delete this picture. We have this kind of system, but this checking this picture is expensive because we are running an AI, and it takes long time. So we cannot run this in the same or exact runtime with HTTP request. So what we can do is when a user register a new photograph uploaded, we just send a message to a queue and say that, hey, check this user's photo. And there's a queue, and these messages just waiting there. And there is a number of the pods, and inside of these pods is a software which checks if it's okay with community standard. If it's not, it's just delete the picture. In this case, we have two scenarios. One, when a message came, we can deploy a pod.
Just one or multiple?
Just one. Second scenario, we can deploy a pod, and this pod continuously ask or Kafka if there's any message, if there's any message, if there's any message. In this case, if there's not many message, you just waste of your resources because there's some container keeps asking, and there's some containers keep says no. But the smart way to do this is like creating a system and deploy a pod for each messages. So you deploy a pod do the job, and then just go. The pod crash itself, pod kill itself, and then go down. And if there's new message, you just raise another pod. Because if you say, oh, I want 5 pods, yes, there's 5 pods, but when the traffic is low, like 3 of them is not used, only 2 pods is used because there's a low traffic. But imagine that you can just create the only number of the pods, incoming messages. And also, if the Kubernetes cluster, you can just make a resource limit and say that, hey, the Kubernetes cluster, if you feel that my Kubernetes cluster, my node resource usage is on the 80%, just limit this pod usage. And then when your server is more relaxed, you can just do the other job. So this means that you have a one expensive process, and you can just balance this expensive process to the time. Most of the systems, this kind of stuff is working at the nights, because at nights, since there is not many users in the system just do the maintenance job or control job or database synchronizations or file processing stuff. Was it answer for your question?
But I'm worried about spin up time because yesterday
It will be slow.
it will be slow.
Yeah.
Yesterday we had experience with Azure, right? And we tried to set up Terraform.
Not that slow. Not that slow. Like couple of seconds slow. Yeah. Like if you just say that, hey, I will just like run a container and response and REST API call from there, it will not work. But if you just say that like 2 seconds, 3 seconds, does not matter, you can just use it. Okay. Another questions about replica sets? Okay. Daemon sets. So we are this is actually the similar thing. We are running some pods, but we say that, hey, I just want this process to run every node in one time. Like usually we use this for utility services like the agents, which is collecting to the logs from the nodes. We are just say that, hey, you can just run this pod in every node. So every physical node has only one pod of one replica of this pod. We are using this for usually utility purposes. In the demo, we will not cover this, but it's good to know that what is it. So that's why I'm skipping it. Oh, and also stateful set. Oh, was there a question over there? No? Okay. So uh, as we all know, if we restart the container, what happens to data? Delete, right? So how we fix this in Docker Compose? Like if I want to run a database inside the Docker container, how can I do that? With volume, right? So this means that you have to connect a physical storage. This can be external hard drive. This storage can be out of your Kubernetes cluster. This can be a disk in your company network. This can be Kubernetes itself storage. This can be S3 storage. This can be anything. Usually, most of my clients has some stable nodes, and they are sending all of the trash, archive, or log data. And the stable nodes has their disk in the company network. So they have a bunch of disk in the company on-prem servers, and this uh, machine is this disk connected to Kubernetes cluster with site-to-site VPN. So they are not storing their log data or trash archive data into Kubernetes cluster. They just, or sometimes because of the legal reasons, they use in some certain country or some certain facility. And usually these this stuff only you can run one replica, because imagine that how you can replicate a database. What happens if you replicate a database? I'm not saying that the database cluster. I'm saying that if you have two Postgres instances, there's an incontin. Yeah, of course. Imagine that your one service is writing to one place, and the other service trying to read the same data from the other place. So that's why you cannot replicate these containers. There has to be only one container. But what you can do is you can just run a bunch of Postgres agents like Postgres pod 1, Postgres pod 2, Postgres pod 3, but you just make sure that these three pods are cluster each other and the data in it is synchronized. Usually, the replicating the write in the database is, well, really complicated stuff. But usually replicating rates is easy and really helpful about the application like the blog site, the social media websites, and we usually do that production. But uh, I only see a couple of times that people replicating write database containers. And also today we will not cover this because also this has a little bit advanced subjects.
What if you want to have multiple copies for backup purposes?
It's actually more like how you manage the database, because the Kubernetes is just make sure your pod's running. But I think that part is more like the database administration. So I don't think I have enough know-how about databases to answer this question. Okay, so when we use which one? So if we are doing like a web servers, if we are doing like regular applications, we are using replica set, because the pods are cheap. You can just delete them, you can just jump them, you can just make 5 of them, and you can just update them. But if you need only one in node for the monitoring or logging, or generally Kubernetes maintenance purposes, we use daemon sets. And if we have the like a message queues databases, like if you're running a Redis, of course we are using a stateful set. If you're running a database, of course we're using stateful set. Um, by the way, most of my clients not using stateful set for database, because it's also common practice to like set up database outside of the Kubernetes cluster. Because if you if you crash your web server, nothing is happened. Kubernetes will spawn new one. But if you crash database, oh boy, you have a problem. So that's why most of my customers, which does not have a 24 hours database team support, they just run a managed Postgres, MySQL, whatever server, and connects that database to the inside of the Kubernetes cluster with site-to-site VPN, and make sure that all of this database responsibility is not in the company, on the cloud provider. And if something's broke or something's crashed, we can just call the Microsoft and say that, hey, give my Postgres back, and they will give your Postgres back. So um, like mid-sized companies, small size, hell no, but mid-sized companies, also we are not deploying too much stateful sets. For Redis instances, since if you just delete the database, probably nothing will happen. And for the queue systems, yes, mostly we use it, but also cloud providers has a really good queue solutions for really cheap. Like in Azure, there's a service bus, and in AWS there's a SQS. So most of my clients rather to pay a couple of bucks to Microsoft and not manage stateful sets. Okay, uh, any questions? Yeah.
Since there are so many interconnections in all all these services, and on top of that, you have Kubernetes, you have idea of pods, you have idea
Yeah.
of these replica sets, etc. What's the real performance cost of all this compared to running everything on a like bare bones server?
Well, of course there's a cost, but uh, you have to manage them in any way. And the Kubernetes is most optimized way to do that. I'm actually not sure how much process is Kubelet using, but I don't think it's too much, because like Kubelet is just monitor the applications and say that, hey, up, down, do this, do that, do that. So with the monitoring and all of the other stuff, I assume that even if you do everything manually, you will always have a monitoring or logging systems. So that's why I'm not adding their costs. But in the other cases, I don't think it's using too much. Not sure 100%. But also, since you will do that in any way, this is the most efficient way to do that. Um, Okay, configuration maps and secrets. By the way, I don't know when we start. I don't know how much time I have. I don't know when is the lunch break left. Okay, so we will talk about configuration maps and secrets. So we say that we have a bunch of applications, bunch of containers, right? Let's imagine that we have 100 microservices, and this 100 microservices all needs to be configured and all needs to be just connect to like some database or somewhere somehow. So how we manage all of the environments of all of these? We have a configuration maps for configuration non-secret variables. You just say, hey, you're a configuration map, your name is application config, and your data is database URL is this, log level is this, and this value is that, and we will apply this, and this will be stored in our cluster as a configuration map. And when we are deploying pod, we say that, hey, use this configuration map. And we can map this configuration map to our pod. And everything in this configuration map will be on as an environment variable, and as in a Docker container, we can access all of this configuration map while environments. Or we can say that, hey, in the pod, I'm just describing environments, use this environment from this configuration file and use that environment from that configuration file. We can just like get all around like a lot of configuration file and give to one pod. And our application will access this as an environment variables. Secrets are similar, but secrets are secrets. So it is write only. So you cannot well, you have to not read them. Usually, we just like it's only accept a base 64. So we add some secret information in it, and also we mesh the secrets with our containers. Also, it is possible to use a KMS kind of solution. KMS is key management system in AWS, which is an encryption system. You can also encrypt these values and using cloud providers key management system to manage this as well. Uh, yeah, this actually basic thing. You can just link to your containers and you can use it. Any questions?
You elaborate on the part you said about KMS is how to manage Kubernetes.
So, well, KMS is key management tool. So, in generally in cloud, when we want to encrypt the data, we just use a KMS for encrypted. We just say, hey, encrypt this data, and when we want to solve it, we just use the KMS case to solve it. It's actually a basic encryption system, but imagine that your private case somewhere in the cloud, and mostly even sometimes you cannot access it. So it is possible to use some helper containers to, like some of my clients, they have a secrets, but inside of the secrets, the values, they just uh, they just encrypt with their KMS key, and in their Kubernetes cluster was running inside of the AWS, and the IAM service role which give them has access to this KMSK. So when they want to uh, solve the data, they just using IAM authentication to get KMSK, and with that KMSK, they just solve the encryption and get the key inside of that. But this is like if you are running this in on-prem environment, uh, you have to find a KMS provider. I don't know, like what type of services are there, but probably there is. But this is not a key feature of the Kubernetes. This is uh, a cloud providers helping you to run Kubernetes.
Is something like identity and access management built in Kubernetes? So in Azure or in AWS or cloud providers, we can set up a policy saying that, oh, this backend service can only connect to that database and nothing else. Is there something similar to Kubernetes?
Well, inside of the Kubernetes, uh, I'm actually not sure.
There is Kubernetes does have like role-based access control. You can create something like a user and have different services run under that kind of user's identity. This does also work with certain cloud systems. So you can say that, hey, these pod or this replica set runs under this service account, and then you can give that service account permissions to do certain things. I don't recall a lot of the details about it, but it's something along those lines as possible. Is that answer your question?
Cool. But it's not very popular, is it?
Well, actually, there's a concept of service account in Kubernetes, but when it comes to network, I think we should introduce some service mesh technologies like ESTL or something. ESTL or
Is ISTIO.
but it's not supported by default in Kubernetes. It's like a kind of add-on.
Would this config map be used at the node level or at the pod level,
It's a cluster level.
cluster level?
So when you have a configuration map, you can just etch it in anywhere in the cluster. But it has to be in same namespace, which I will explain it later. Any other questions?
Why do you think we use base 64?
I have no idea, and I think it's like, I don't want to say, but I think it's kind of stupid way, because
Just encoding.
yeah, like it's not even secure, right? I don't know why, but if you don't use it, kubectl produce an error. I'm not sure why. Maybe it's because of not losing any data while transferring. Let's imagine that there's a Korean letters in your password, and transferring this to UTF-8 supported place. It's just a lucky guess. It's just a lucky
Yeah,
guess.
makes sense, yeah.
I'm not sure.
Yeah, I think I have answered to that. So exactly that. When you encode to UTF-8, it's fine, but when you decode it and the character doesn't exist, UTF-8 uses a default character, which will basically mess up the decoding, and you could end up with invalid string. We invalid output. So
Yeah.
this for serialization reasons and transferring between nodes, I guess.
Yeah. Well, probably, because also, like in entry point, I'm transferring this with the API call, so probably it's make sure that the secret is the same. Yeah. So also we have services, and this services is actually fixing our service discovery solution, which we talk about. So let's imagine that we have a container, and this container is a backend container, and we also have a front-end container. So this front-end container has to call this backend container. But what is the IP? We don't know, right? And every time this pod restart has new IP address. So we need to just like register this IP address to somewhere and manage it there, like a DNS. So what service 2 is service actually a DNS point. So service has some different types. We have a load balancers, we have node IPs, and we have internal services. When you create an internal service, it says that, hey, if you access as a demo service, and the service also has an internal IP address inside of the cluster, if one container calls the other container with this service IP or with this service DNS, and it will reach the IP address of the container. But how we connect a service and a pod? So as you can see, there is a selector over there. So this selector, I'm saying that, hey, I'm selecting the application demo. So if the pod has application demo in it, this service is just recognize that pod as an entry point. So imagine that if you have 5 different services, 5 different pods, and these pods is continuously restarting and continuously changing the IP. When you go with this service definition, you will just land one of these pods. Yeah.
And to be clear, that's a lot here. When you do your pod definitions, usually through a record or something, it's either an annotation or a label I forget
Yeah.
which one it is exactly. But you have to define either an annotation or a label to look up which one it is. But that's what the selector matches against. Okay. So you don't just say, oh, it's this application. Kubernetes magically knows what application it is. No, no, no. He has either some annotation or label called app, and the value for that annotation or label is demo. And the Kubernetes will use that to identify which pods match that criteria, and then do this forward. Sorry, just wanted to add a little
Yeah.
clarification.
Yeah. So we have a different type of services, as I say. If you have an internal service, this means that your service will only available internally. So like if you have another pod in the same cluster, uh, that other pod can come to the other pod, and we usually use this for inter-cluster communications. But there's also something named mod IP, and this means that this service will be available on node IP. So if you know the IP of the node, and if you visit that IP address, this means that this will redirect your traffic to that pod. But why you need that? Because since we can have a multiple nodes, and time to time we also destroy the pods and destroy the nodes and adding new nodes. So if you just say that, hey, this is my node IP, and if you just like connect everything to this node IP may also change or only go to that exactly node in it. So that's why we have something named load balancer. So when you create the load balancer, this creates an external IP address outside of the cluster. And if you are running this in on-prem, it's really difficult to set. But if you are running this inside of a cloud provider, when you say that, hey, load balancer, the cloud providers gives you a load balancer with external IP address. And when you go to that load balancer from outside of the Kubernetes cluster, you can just run the service. And even the nodes change, even the node IP address change, no matter your application will be no issue. But do we use this while really hosting an application? Actually, no, we are not. Because we have another thing named ingress. Ingress seems like this. And this ingress is, you can think that it is kind of Nginx. It's actually Nginx based, usually, uh, for managing the HTTP network inside of the cluster. So you just say that, hey, I have an ingress, and this ingress have an external IP address. And you have an ingress configuration file like this. You just say, hey, I have an external host address here, and this is the host address, and I have a TLS certificate here for making the SSL is working, and then you just like write the rules. If this is coming with this path, just redirect this to this service from this port. If it's coming from this path, you can just redirect this to the user service, or you can just like play with it like playing with an Nginx. Because if we open a service on a load balancer settings, this means that every service you deploy has own external IP address. And we don't want to do that because we want that we have only one API output, and inside of this API output have hundreds of different microservices. And also the IP addresses is expensive. I think it's $5 or $6 per IP address per month. So that's why we try to use as less as much as less IP address. So it's also helped that.
So that was a really slow transition. But I worried it made basically nothing. So services are for routing within the cluster. Okay? So you define a service so that services can talk to each other, and so that you have an endpoint, which is another object, but we won't get to that, I think. that you can basically reach the pods through. Okay, so services is how you get to pods, right? And then in ingress, you can think of an ingress as how you get to the cluster from outside. Okay. Ingress, like the word means, entering into an area across some threshold. Okay. In this case, the threshold is the edge of the cluster from something outside the cluster channel, usually the internet. Right. So your ingress, your rules are basically how to access each service within the cluster. If you still have to define services for your pods within the cluster. Now, a thing that Emma hasn't demonstrated here is that you can also set up some domains for each ingress as well. But that's just a different way of doing it. So you can do some domains or you can do path-based. They both work quite well.
And you have a multi-region ingress or multi-region cluster, and can Kubernetes route the traffic in a smart way as if you had like DNS geolocation or something. Is it
If you take your physical nodes, it may be possible, but like you have to take all of the resources you have. You have to say that, hey, these are in North America, these are in Asia. You have to take all resources, and you have to the custom rules that, hey, like replicate this pod, but put 5 of them here, put 5 of them here, and take all of them, and take the Nginx, because if you have only one external IP address, probably it will be in some place. So like even you're in Asia, even your pod in Asia, but if your H point of your cluster is in North America, you have to travel North America, come back to Asia, get the response, travel back to North America, and go back to your client. So this means that you have a multiple IP address, and then if you have a multiple entrance and entrance point of your cluster, you can just say that, hey, I want to use the DNS services to geographically go to the other IP addresses. But in this case, you have to make sure that the IP address you define to that particular region's DNS has to be at that running at that particular node. And you maybe, I'm not sure about it, you maybe do this with the tagging the resources and putting the rules, but I'm not sure actually.
So when it comes to kind of global routing, there's a type of device called a global traffic manager, a GTM. To be perfectly honest, I've never worked with one directly. I just know they exist. I'm an architect background and had to deal with incidents where they broke. But that there are ways to do kind of that global IP address management and global routing. I don't exactly how what kind of sort exists. From a Kubernetes perspective, to Emily's point, when you're defining an ingress, it's defining an entry point on the nodes of the cluster, right? So if, and correct me if my memory is wrong, it's been a little while, but if I recall correctly, you know, there's all different kinds of services. One of the services that Emma mentioned is the load balancer service. And if I remember correctly, you define a load balancer service as your kind of your externally facing service that then you can then configure ingresses on. And usually in the cloud system, when you define that load balancer service, it allocates the cloud provider's load balancer.
If you're in cloud.
If you're in cloud. So if you're on like Amazon, for example, and you have everything configured properly, when you create a new load balancer service, it will define a new application load balancer by default, by recall correctly. But that is usually scoped to a region. So if you want to do crazy global traffic management stuff, there might be cloud-based features for it, but they would be on the more advanced end, and you have to go re-up on them. If you want to do it yourself, then you have to figure out how to do global traffic manager yourself. And honestly, I think that's beyond our knowledge. And how far beyond the scope of the bootcamp? Because this is supposed to be 50 years. Great question.
Yeah. Like I can only like imagine that how to do that. Like probably there has to be multiple entry points, because if there is multiple entry points, there may be no way. If this is in AWS, and if you somehow manage to have a multiple entry points, and if you manage to redirect this traffic inside the cluster, well, you can use global accelerator of AWS to manage the route traffic. But yeah, I think it's a like really premium knowledge subject.
Find this inverse configuration, does it apply on every node you have? This one in particular?
Yes.
So it's like opening the ports like you specified.
Well, it's actually not opening ports. Like you mean opening ports external? No, it's not.
So I don't know about it apply. So an ingress is a cluster level concept. And the ingress uses the load balancer service to manage inbound traffic. Right, the load balancer service is the actual externally facing endpoint. The ingress is what manages traffic coming in. And then the ingress routes it to the appropriate service as defined by the rule which we're recommending. Is that accurate?
Yeah, correct.
Yeah.
So it's actually not exposing any of these ports to outside. It's just using load balancer to redirect them. And also that load balancer is usually Nginx. So it's actually like this is a fancy Nginx thing, but in like what is running like under the hood is just an Nginx with bunch of configurations. Okay, so I think we already talked this. So you can just add a volume to a pod, and you can just put this volume outside of your cluster as well. As I said earlier, you can just have a disk in your company office, and then some pods just use this place as a volume, or you can just add S3, probably not S3, but you can just add elastic block storage, or you can just add the cloud disk to this space, and you can just put your logs or put your data in it, and this will help you to separate the pod's life cycle and the data's life cycle, because when every time pod restarts, data will lose. So that's why you can do this way. And also putting the storage outside of the cluster is a really good pattern, because most of the big clients, they want their data, like some type of data, to inside their building, usually in a some really secure. I'm talking about my clients like banks or insurance companies. Usually they have a like secure rooms with like bunch of people with guns waiting outside, and the disks are usually there. So when you're running this Kubernetes cluster in Azure, you can just dump the data to this disk, and it is really useful. Um, well, I think this is enough for this case. And also resource allocation. So technically, if you don't add the resource limitations to a pod, it will be still running. But if you not add it, it will be running like crazy. So it's better to add it. Running like crazy. Like they can just like use the whole memory of the cluster. So we usually define some resource limits. We usually have two type of limits. We say the request and the limits. So the request is, I'm asking this container, hey, can you just use this much of memory if you don't mind? And the container try to keep that much. But if it cannot keep that much, it will just extend as much as the limits. So the limits for the container, for the pod perspective, limit is the hard limit, that the maximum memory this pod can allocate. So usually what we do is, if we have a 10 gigabytes of RAM, and if we run to 15 containers, we are just giving the physical limits 1 GB each, and we are assuming that they will never reach that level. We are overloading the cluster, but if somehow everyone will start to use the limits, this means that our Kubernetes cluster will be crash. So we have some kind of automations that can just get another node and connect in the Kubernetes cluster and extend the resource capacity. But this is only possible in cloud, because in cloud, when you say this, Microsoft gives you more RAM and memory. But in on-prem environment, when you say this, your IT guys look your face and say that, oh, it will take 3 weeks because they have to physically get some servers.
And this can be both problematic and very helpful, because what will happen is if the node that the pod is running on is starting to feel either memory or CPU pressure, basically it's getting a high percentage of utilization, it will start it is called eviction. It will evict the pod. It'll be like, nope, you don't live on this node anymore. Get out. It will kill the pod, and then Kubernetes will orchestrate running the pod, hopefully on a different node. Now this is good and bad. It is good because it prevents the node from crashing and killing all of your pods. However, if you did not configure sufficient limits for the pod, like maybe you gave it a limit of like half a gig, but it normally runs at 2 gigs, well, then the pod just going to get evicted all the time. It's not good, right? So it is important to have some understanding of the expected behavior of your applications before you set these. And if I remember correctly, correct me if I'm wrong, Henry, but I believe that if you don't set a limit, it's kind of a higher priority for eviction, if I remember correctly.
I don't know the priorities.
Because I think there have been times where I think I left off the limits at one point on some service, and it was always the first service you kicked off. And I was like, what the heck? So yeah, definitely have a good idea of how your application is going to run. If you and your organization can afford to do load balancing on your applications, definitely do that. But it is the really positive side is that, you know, if someone introduces a memory leak, you're not going to kill everything. If an application has a memory leak, eventually it'll grow beyond its limit. The cluster will evict it, and then it'll restart on some other pod, and then we'll have this as usual. It'll be fine until it has its memory leak again. So it kind of protects you in that way, but you know, this is why monitoring is important. Because if you see that some pod continuously get infected, you gotta look at something.
Yeah, like always at limit. Like it does not matter how much you add, but always at limit. It's a good practice. And like if it's a dev cluster, usually we have like we like the total limits of the cluster and total the resource we have in the nodes, usually like 1 to 2. Like if we have a 10 gigabytes memory in physical node, we just give limits 20 because it's in the dev, and if it's crash, no worries. So for just playing perspective, but in production, we usually not go beyond 10% extra, and we are keeping eye of everything, because if something leak, then it will be catastrophic for the all of the cluster. So yeah.
Sorry, one more thing to add, because I wasn't sure if the request part is there. So we're talking about limits, right? But requests are to make sure that Kubernetes puts your pod on the correct node. So let's say a node is at like, let's say the node has 10 gigs total, and you say, hey, this pod requests like 2 gigs, right? And let's say the node is currently at 8.25 gigs or something like that. It's actually only to try to put the pod on that node, because it knows that there's like a request is kind of the expected amount that you want to reserve for that pod. And Kubernetes will try to make sure that whatever node it puts it on has that available space. Now, the problem with that is if you set your request too high, then Kubernetes may not be able to find the node to put the pod on. And then if you're setting it up on the cloud with a node automatically allocated on the node, but probably allocated on the node running money that's static. So your requests should be what you expect the minimum to be necessary for your application and the limit for what you expect the maximum to be. And that way, if it goes beyond the maximum, then it gets affected because you have this problem. And you set the request to the minimum to make sure that, it has enough resources to let at least get started and running. Because, for example, I've had instances where I was trying to run Elasticsearch on Kubernetes. I do not recommend, by the way, it's paid. And it got to the point where basically, Java is very memory heavy. So I kept having like limits up to like 6 gigs. And so it would basically each Elasticsearch pod will basically take up a whole node by itself. It's like, what am I doing? Definitely check this out. Get an idea of how your application is going. Create the class with minimum and let it says maximum. It's my special application.
What's the CPU unit over there? It says 500 and.
Yeah. So they had a their own calculation system. So it's obviously not means that like 500 CPU.
So it's like millisecond.
Yeah.
So 500 is half a millisecond.
Yeah.
1,000 is 1 CPU.
MI is megabyte.
MI is megabytes.
Yeah.
I don't know what it's I, but yeah.
So how could you like cross nodes because one CPU is not the same as the other CPU on different machine, right? So it sounds kind of weird. I mean,
How else would you do it?
there's a thing, a metric called jitter or jet or something like that in Linux kernel, and this is how they measure powerfulness of the CPU.
Maybe you should see it.
Yeah.
But
Yeah.
I think they want to do this CPU and no CPU concept because these days, even if you set to VM, you're not setting the clock speed, you're just requesting the number of CPUs, right? At this point, the individual speed of the CPU is less concerning, and it's more how many concurrent tasks can you run. That's what we think about these days. So I think that's why they went with this model. So it's like, do you need a whole CPU's worth of compute? It's half CPU, okay, this kind of thing. So I think it's generally just an approximation. I don't think they get so specific that they need to use the actual accurate bit. But that's better design for the minutes. That's just how I interpret it. But in terms of practice, it makes sense to me without anything fixed. And when I'm benchmarking my applications, I figure out what CPU it's on. Yeah, it's about X. Okay, so I'll set this to 500 millisecond. And that's worked well enough for me.
By the way, usually if you're running in cloud and if you don't have a special purpose, all of our nodes has similar CPUs because we are not demanding different CPUs from the cloud. And also we are running in not physical machine, virtual machine. So the CPU the cloud provider gives us is also not a real CPU. It's just a hyper CPU. So yeah.
Talk about volume and then
Yes.
We can store databases.
Yeah.
And volumes can be stored in the pods and external cluster. Yeah.
Not in the pods, but in the cluster. Yes.
Then we can connect our app to database with name, but in simple apps we can our media files or kind of files in in the same folder, in the same level of the application, but in the case of we can how we can store our files in memory.
So, like
No,
it's
in volume.
well, it is a similar way. If you want to write some file to a folder, you can just like attach a volume to that pod and write there.
While we coding,
Yeah.
we should attach the volume.
Not while coding. While coding, just write it somewhere in the disk, and attachment of the volume you just doing while managing the Kubernetes cluster.
So what you do is the workflow when you need persistent disk for a pod is usually you do a stateful set because the fact that you need a persistent disk means that you're maintaining some kind of state. So you define your pod as part of the stateful set. Also, as part of that stateful set, you define a persistent volume claim. And what that will do is, ideally, you have allocated some persistent volumes, basically disks, to your cluster. But those disks are bound to some node of the cluster, usually. It's been a while since I've done all this. But basically, when you define a persistent volume claim for a stateful set, it basically associates the set with a specific disk on a specific node, usually. And so what happens is when you define this persistent volume, you basically mount it basically like a file system. So you have this persistent disk and you mount it into the pod at some path in the pod's file system, and then you just use it like a local disk. Does that answer your question, or are you looking for something different?
What we will be processed? We save the file. It will it automatically save to the volume
So
at the same time.
So earlier I mentioned when you define the persistent volume, or when persistent volume gets matched to persistent volume claim or a stateful set with that pod, right? I have to call all of that. You mount it to a specific path on that pod file system, right? So you might define some path called /data, right? And the volume will get mapped to that path. So anything you write in the /data volume, anything you write to that /data directory gets written to that persistent volume because you mounted that volume to the /data directory.
Yeah.
So if you're not really familiar with this, I recommend looking up about file systems and mounting. If you learn a little bit about that, it'll kind of be like that. But when it comes to things like uploading file, I actually don't recommend using persistent volumes because there's no reason that a specific pod needs to know where a specific file is, right? You just need the files somewhere that some pods can access to, and that's when you usually use a service like S3 or Azure Blob Storage or Google Cloud Storage, something like this. But I don't know your exact use case, so maybe it doesn't make sense to use persistent volumes. We have to talk more about what's specifically. But I think we have one more slide left, and we're almost done.
Yeah. Yeah. So live props. Sometimes we have to understand that if our applications are working correctly or if they crash, because for example, one of the use cases, if a container is not working properly, we don't want to send the traffic, right? So there's 3 ways to do this live control. We call it health checks. So the one way, you can just create an endpoint in your application, like this health check endpoint. And if I send a request there, and if I get 200 requests, I assume that this pod is healthy. Or I can just check a port, and if this port is open, I can say healthy. This is the second method. And the third method is I can run a CLI command inside of this pod's terminal. And if the result is something, I can say that, hey, this pod is healthy. So Here we are describing HTTP prop, and I say that in this path, in this port, if you go and if you get like success for 5 times, this is healthy. If you get fail for 5 times, this is unhealthy. And please wait 10 seconds after your container or after your pod initially running for the make your pod to be ready. And usually inside of these health check points, we are writing inside of the code, we are writing something like, hey, can you access the database? Can you access the S3? Can you access this uh, external APIs? Like what your application is dependent on. Like let's imagine that we have an application. This application writes files to S3 buckets and also this access to a database. So since accessibility of these two resources is necessary for me, I'm writing inside the health check endpoint that hey, uh, check if the database is accessible, check if the S3 is accessible. If they are accessible, just respond at 200. And when you deploy this pod, uh, sometimes it may be also unit test. Some people do that. Personally, I'm not do that, but also some people write unit test over there as well. When I deploy this container, this pod to the my cluster, I told you the replication says let's assume that I want 5 working containers and they all version 1, and I want to deploy the version 2, but I will just close and update one by one. So this is how the Kubernetes knows that if a container lives or not lives. And if a container is already crashed, what the Kubernetes do is try to make sure to the same as a state file. If there's a state file, if it's a deployment, if there's using replica set, and if the state is there has to be 5 containers, and if there is a healthy 4 containers, it will just kill the unhealthy pod and deploy it again. And while doing this, it will create an event in the Kubernetes API. And if you have a monitoring tool set up like Grafana, Alert Manager, like that kind of stuff, you can also cache these alerts and alert the administrator to, oh, there's a one pod and keep crashing for that many minutes. And then you can just do a bunch of automation and bunch of cool stuff with that. It's simple. It's just check if it's live or not. Any questions? Like general any questions? Because this is the last slide. Yeah.
So is the part where you expose the cluster to the internet? Where does it happen?
Ingress.
Ingress, but you said that in the ingress, you only define services that are kind of internal.
So
Where does it happen there?
the services is usually work internally, and you are assigning an ingress. Ingress is the entry point, edge of the cluster, and the ingress redirecting this traffic to the services. So ingress is actually the entry point. But when you deploy ingress, what is actually happening? A cloud provider is deploying a load balancer out of your cluster.
Is it in a config file Kubernetes, all the DNS names and ports, or
Well, you say the internal, external.
like deployment service?
Yeah.
And it has like domain name and it has like port 80 and
Yeah, in ingress configuration, you can say that which domain or subdomain it will connect or which SSL certificate it will connect.
If your Kubernetes provider is also hooked up to DNS, it may allocate the DNS for you. Otherwise, you may have to go get the IP address of the load balancer.
Yeah.
But yeah, like let's say you're using GTP, and you're using GTP to manage Kubernetes, and you're using Google DNS for your root zone, then it'll just automatically do it.
and how do you need to specify the host names? I mean, yeah, host names. But
Because what GCP will do is when you define the ingress, you have everything configured properly, it will automatically create a load balancer service for you. Allocate a load balancer in Google Cloud Platform. Create a DNS entry based on your ingress configuration, and then configure that DNS to point to the load balancer that it allocated.
But this will only if you are in the cloud provider. If you are not in the cloud provider, you have to like find a product which do the similar thing for you, or you have to do manually, or you have to do the scripting.
Yeah, makes sense. I'm just wondering how does it work without a provider, for example, on premises? Like, do you need to, like, you set up this file, right? Does, where's the entry point? Like, I have the node, I need some ports, right? And
So earlier he had shown one service definition. When you create an ingress, I don't remember if it's automatic or not, but normally services are meant for internal use, except for the load balancer service type.
Yeah.
That one is your external entry point, and that's where the ingress route, or the load balancer service routes to the ingress, which then routes to all the other services. And the load balancer service, there's a bunch of different ways to do it. I believe there's one load balancer called like bare metal or something like that. Or
Well,
basic. Do you remember?
Like I only worked with bare metal Kubernetes cluster one time at Equinix, and they were using some Nginx or F6 clusters, F6 load balancers.
I thought. Yeah, okay.
But I actually don't know that much because my clients usually on cloud.
So for on-premise, you'll have to look it up because you have to figure out how you're going to do your. There are a few well-supported configurations out there. Like I've done it once or twice as well. If I remember correctly, the easiest way was basically you designate one node as your load balancer node, and then it just reserves ports 80 and 443 on there, and there you go. You give that node's IP address to your DNS, and then you're good to go. You better hope that node doesn't go down.
Yeah, if you lose the node, you will lose the whole internet traffic.
Does that answer your question?
yeah, perfect. Thank you.
Yep.
Anything else before we break for lunch?
If you also have any additional questions, we can take before the next session because we have a limited time for eating.
Good point. All right, guys. So let's
Let's
so
eat.
thank you, and
Welcome.